So this is video 2, solutions. The physical property demonstrated in the first problem is solubility, as the gas dissolved in liquid can be identified as a supersaturated heterogeneous mixture, which is technically a suspension that wouldn't regularly occur due to the nonpolar property of diatomic oxygen and polarity of hydrogen dioxide. The variables in this mixture involve temperature, solubility, polarity, and an implied constant pressure. It can be determined that as temperature decreases and pressure increases, more gas will dissolve in the liquid because the molecules are more tightly packed and can escape. More oxygen will dissolve in cold water because if it were room temperature or hotter, the gas particles would get excited and try to escape. In the second problem, the physical property in this statement is polarity, and how polar substances like water dissolve other polar or ionic substances due to the asymmetrical arrangement of the molecules. Due to the law of like dissolve like, which states that polar solutes are more soluble in polar solvents and nonpolar solutes are soluble in nonpolar solvents, the colligative properties of a solution depend on the quantity of particles dissolved in the solution. The variables involved in this statement involve the polarity of molecules, and it can be determined that polar substances will dissolve only other polar substances. And the third, for these three diagrams, the physical property of boiling point elevation is being used, which states that the boiling point of a solution is higher than the boiling point of a pure solvent, and the greater the number of ions in the solution, the higher the boiling point. Variables in this demonstration are temperature, concentration, mole value, and the quantity of solute and solute particles. Sample A is shown as a slightly concentrated solution. Sample B is just the pure water solvent with a boiling point of 273 degrees Celsius or 373 degrees Kelvin. And sample C is a more highly concentrated solution than A. Therefore, the arranged diagrams in order of highest to lowest boiling point would be sample A, then C, then B.